Hello everyone, this is Sukruti Joshi from LG Institute of Engineering and Technology, Ahmedabad. I am going to take the video lecture series on chemistry. The subject code for chemistry is 311001. In our previous sessions of this particular subject, we have started chapter number 6, which is fuel and combustion. Right? In fuel and combustion, we have studied the types of fuel, what is the meaning of fuel, what are the classification of fuel. Afterwards, we have learned about the combustion process, right? In which we came to know that how many types of actual fuels are there. So as we all know that we have two different types of fuels are there. Number one, primary fuel. Number two, secondary fuel. Primary fuel means natural fuel, while secondary fuel means the artificial ones, right? Depending upon that, we have seen the examples. Depending upon that, we have observed that how it is possible for us, that what are the characteristics of a good fuel, or how we can say that this kind of fuel is a good fuel, right? So we need to understand it here properly, that which kind of particular fuel is considered as a good fuel. Fine. Now, after seeing the characteristics, which involves different things, which involves the types, right? Afterwards, we have started the part which is solid fuel. What is the meaning of solid fuel? The fuel which is obtained in the solid state is known as solid fuel, in which we can take an example of wood, peat, lignite, coal, coke, anthracite, etc. And even we have seen their properties also, that how their forms are actually changed and how we can utilize them. Because depending upon their rank, depending upon their carbon rank or coal rank, we can use them in different applications, right? Their uses are actually changes from the type of carbon chain or from the number of carbons which are actually present in it, right? So how we can know that this kind of fuel is available in this particular application or in this particular field? For that, let's take a look on each and every solid fuel one by one. Here, the first one, or we have four different columns available. The first column is fuel. Second column is percentage of carbon. How many percentage of carbon is present in that particular kind of fuel? Then third one is calorific value, which will be given in kilocalorie per kg. Okay. And the last one is applications. So we have four different particular columns, and we will get the information about them one by one. The first thing is wood. So wood contains 50% of carbon. The calorific value will be from 4000 to 4500 kilocalorie per kg. So when we burn 1 kg of particular wood, we get approximately 4500 kilocalories, right? This is the meaning of it, and it is widely utilized as a domestic fuel. Afterwards, we have the next one, which is peat. So wood gets converted to peat. Okay. So peat contains 50 to 60% of carbon. So as we move ahead, the percentage of carbon is continuously increasing, right? So here you can see it contains 50 to 60% of carbon. Now, it will give rise to 4125 to 5400 kilocalorie per kg. As you can see, the number of carbon or the percentage of carbon increases, the kilocalorie or the calorific value of that particular fuel also increases. Now, when the calorific value of any fuel increases, along with it, its usage is also increased. So, it is used if deficiency of high rank coal is prevailing. right? If we don't have anthracite, then we can use peat, right? Afterwards, the third one is lignite. So now let's talk about lignite. Lignite has approximately 60 to 70% of carbon present in it, and the calorific value will be ranges from 6,500 to 7,100 kilocalorie per kg, right? As you can see, the percentage of carbon is tremendously increased and the calorific value is also increased. Now let's see that how their use is also increased. So it founds its application for steam generation in thermal power plants. Okay. Again, it gives rise to a very high amount of energy so that it is widely used in thermal power generators. Okay. Next is bituminous. Bituminous coal. Okay. Bituminous coal contains 80 to 90% of carbon. It generally contains 80 to 90% of carbon. That means its calorific value will ranges from 8,000 to 8,500 kilocalories per kg. Right? It gives rise to tremendous amount of energy when the combustion of bituminous coal is done. Okay. It is used in making coal gas and metallurgical coke. Okay. Again, it gives rise to very high temperatures. It gives rise to very high amount of energy. Because of it, it is used in metallurgical coke. Okay. Now, last but not the least is anthracite. Anthracite has 90 to 98% of carbon. It depends upon its sources, but it generally contains 90 to 98% of carbon present in it. A very less amount of moisture, a very less amount of ash, very less amount of any kind of volatile matter is present in anthracite. Okay. So here it gives rise to 8,650 to 8,700 kilocalories per kg. So its calorific value is increased tremendously, as you can see it here, right? Now let's see its application. So it is used in households and it is used in steam raising at a very high scale. Okay, not a normal one, but at a very high scale. It is widely used to provide the fuel to households. It is used, like if we burnt it, we will give rise to it at a particular number of houses. It will not be like that it will provide energy to only one house. It will give rise to n number of houses. Okay, this is how we can differentiate this wood, peat, lignite, bituminous and anthracite. Okay, let's move ahead to the next point, which is very important for all of us when we deal with any kind of petroleum industry, which is analysis of coal. See, coal is available almost everywhere, right? It is utilized everywhere. Its application is found everywhere. But how we can analyze it, that whether it is perfect or whether it is as at a level that whatever we have given or not. So as a scientific person, as an engineer, we have to understand that how we get a perfect one or how we can get the analysis of coal done, right? So the analysis of coal is helpful in its ranking. We have to rank the coal, right? It is known as coal rank. Depending upon the coal rank, it gives rise to its calorific value, and depending upon the calorific value, it will be utilized. Okay, so the assessment of the quality of coal is carried out by these two types of analysis. First analysis is proximate analysis. Second analysis is ultimate analysis. Okay, we got two different types, proximate and ultimate. Now, the first one, let's take a look on it in detail, which is proximate analysis. Okay, proximate analysis is basically the analysis in which the percentage of carbon is indirectly determined. Okay, it is a quantitative analysis of the following parameters: We will take a look on this particular parameters in order to get an idea that how many number of carbons are actually present, how many percentage of carbon is present in that particular kind of coal. Okay, so first is moisture contained, second one is volatile matter which is present in it, third one is ash contained, and last but not the least one is fixed carbon. Okay, these are the four criteria depending upon which we can analyze any kind of coal and we can analyze the percentage of carbon which is present in that particular fuel. Okay, here we will take a look on them one by one. Let's move ahead to the first one, which is moisture content. Okay, moisture content can be determined through a particular process for which we have to undergo different type of steps, right? So first of all, let's take a look on that steps, and afterwards let's take a look on its calculation also. The first is about 1 gram of finely powdered air dried coal sample is weighed or in particular crucible. We have to take 1 gram of finely powdered air dried coal into crucible. That particular crucible is placed inside an electric hot air oven, right, which is maintained at approximately 105 to 110 degrees Celsius for 1 hour. Okay, the crucible is allowed to remain in an oven for 1 hour and then it is taken out, cooled down and weighed. When we weigh it, we have to put it inside the desiccator. First we have to put it inside the desiccator and then we have to take it out and weigh it. Okay. Now here the loss in weight is reported as moisture. Understood it properly? We have to weigh it before and afterwards, after put it inside the crucible, inside the hot air oven, we have to again weigh it. Okay. So here what we get an idea that the percentage of moisture can be calculated by the particular formula, as you can see, that is loss in weight divided by weight of coal taken into 100, right? How much we have taken and how much is left. The difference is the moisture. That moisture is evaporated in hot air oven and we get the exact weight of our coal, and in that manner we get an idea that whether it contains how many amount or how many percentage of moisture in it. Okay, next we will see in our next session. Thank you so much everyone.